Alright, so we are doing systems of equations today, but with quadratics. In case you guys forgot, systems of equations are whenever you are solving two equations at once, finding the point that they have in common, or in other words, where they cross. You were. Oh. So, once again, systems of equations where you have two functions and we want to find where they're intersecting. So on the top row we have a quadratic or a parabola with a linear function, right? And those are your three possible outcomes. They may not touch at all. They may have one solution or two solutions. Okay. You could also do a system of equations with two quadratics. Once again, same thing. They could have no solution, one solution, or even up to two solutions. Okay, so we're going to solve a couple today. Got it. I don't think I'm going to have you guys copy this, but I do want you guys to kind of just observe and participate with me here on it. So, what is the solution to the system of equations? So in this case, what I want you guys to do is I want you to understand what a solution is. It's the place where they cross, right? So that would be here and here, and they're not really crossing at very nice points, so we're just going to estimate. But one place where they would be crossing, and I noticed that my graph is going by twos. Do you guys notice that? That's kind of important to pay attention to. So this would probably be about x equals 1, right? And then the height looks like it's 4. This solution over here, this would probably be 6, 8, probably 10, right? So here, in between 8 and 10, that would be 9. And the height would still be 4. So this would be our solution. So that's how you can, find a solution by just looking at a graph. It's pretty easy. You just name the points where they're crossing, right? But when it's equations, we got a little bit more work to do. So we don't have a graph, but we have the equation. So let's do that. Go ahead and write down example 1 there. As you guys might recall, when it comes to solving a system of equations, we have substitution and we have elimination. Those are our two options. And technically, once again, either one of those will work. I think I'm just going to stick with a substitution approach today. So notice here that y equals negative x plus 4, right? So what I'm going to do is I'm going to plug that in for the y in the other equation. Now, if I wanted to solve this from here, we're going to do what we did back on our first lesson. We want to, since we have a quadratic here, we want to move everything over to one side so it equals 0, so that we can use the quadratic formula. So that's what we're going to do here. So let's go ahead and move the x's over and the 4. Now it equals 0. Okay. And so we're going to solve for x. And that's where we're going to use our quadratic formula. So we have x equals negative b plus or minus the square root of a squared. What's that? Yep. Substitution. So my b in this case, looking at this equation, is 2. My a is 1. And my c is negative 3. So that's going to be 4 plus 12, which is 16. Square root of 16 is a pretty nice number. That comes out to be 4. And since we don't have a square root anymore, we're going to go the extra step now and split it up into 2 equations. So we have x equals -2 plus 4 divided by 2. And we have x equals -2 minus 4 divided by 2. So this one gives us 2 over 2, which is 1. This one gives us -6 over 2, which is -3. Now at this point, you might be tempted to be done because that's where we always stop when we do the quadratic formula, right? But you remember we're doing a different kind of problem now. We're solving a system of equations. When you have a system of equations, it's a point. And a point has an x and a y, right? So we need to find the y values that go with each of those x's. So we have 2 x values. I've got x equals 1, and I've got x equals -3. Okay? So what we're going to do is, it doesn't matter which one you pick, but just pick one, plug in the number, and you get your y. Obviously, we'd probably want to pick the bottom one because it's simpler, right? So let's do that. So in this case, you get 3, and in this case, you get 7. And so the solution to this system is x equals 1, y equals 3, and x equals -3, and y equals 7. That's that. All right, so there's our solution. And that's pretty much how you do it. There's really not much more to it. So I'm going to let you guys go ahead and work on these 2 problems here. Go ahead and see if you can find the solution of both of these. So that I went ahead and graphed number 2 just so you guys can see why we end up with a negative under the square root. It's because they don't touch. There is no solution to the system there. Just for the people on the video, I want to write down these answers really quick though. For number 1, it was it 2 and -4?
Yeah.
And then when I plugged in 2, was it 7? And this one's -5?
Yeah.
Thank you. All right, so there's our 2 solutions. Okay. All right. Let's go ahead and move on here.